So let me move to the background information that I've put together from the BGS and from London's foundations, because those were two accessible sources I thought were valid. First of all, the BGS information tells us, gives us a description here of the lithology. Gravel and sand, clayey near the base. We've got quartz, quartzite, lower greensand chert in fine fractions. We've got a matrix of orange-brown, pale grey, red mottled clay, sandy clay, pockets of coarse sand, layers of silt, clay or peat. It's a complete mixture. This is where I started to think this is very confusing. It tells us that the Stanmore gravel rests unconformably on London clay bedrock at this height, at this elevation, thickness of 4.8, and it's overlain in places by till of the Anglian, but generally it's at the surface. So I thought about that for a little while. I'll come to that in a moment. Then I looked at London's foundations and I found this information. The river terrace deposits in the London district can be separated into two systems. The older terraces predate the Anglian glaciation. They mark northeastward flowing tributaries of an ancestral river Thames, which at that time flowed through what is now Hertfordshire and Essex on its way to the North Sea. I think this is just to remind ourselves of what Peter Allen was talking about in July, where we were looking at those maps of the ancestral Thames. Then it says the advance of the Anglian ice sheet diverted the Thames southward to approximately its present course. The younger system of river terraces follows the course of post-diversionary Thames and its tributaries. So the Stanmore gravel is the older one before the Anglian ice sheet. That's what we're talking about, right? Please correct me if I'm wrong, because you know I don't know anything about this. I'm just reading what I can and trying to understand it. So I found these two figures from London's foundations, which shows the Stanmore gravel here higher. And obviously as the river cut down, you get the later deposits at a lower elevation. And then here on the stratigraphic column on the right, you see the Stanmore gravel is right down the bottom. It actually says it's Pleistocene. I'm not sure whether we could say it's on, I've seen that it might be Pliocene, actually a bit older. But in any case, when we're thinking about the Thames gravels, it's way down there, much older than most of them. Okay, this is London's foundations again. It tells us that there's a hilltop occurrences of gravel between 130 and 150 elevation, and a description that we've already seen, I think, in the BGS. Then the next point in London's foundations goes on about the Stanmore gravel is of uncertain age. This is what I put on the original slide that I showed you as the introduction, where it asks, its distribution suggests that it's a westwards correlative of the Red Crag of East Anglia. I kind of would like that explained to me, if anybody can just explain to me what the westward correlative means. And as such, it could yield significant information about the early Quaternary paleogeography and climate and the long-term rates and patterns of vertical crust movement. That hasn't been, I didn't find that anywhere else, but the actual uplift is obviously relevant in the Thames cutting down, isn't it? Found a nice picture of the Red Crag. I don't know, if you look at that, does that look the same as the Stanmore gravels? So I'm just a little bit confused on the Red Crag thing. So if anybody can help on that, and I'm going to hand over hopefully to Professor Bridgland in a moment. So these are the things that I felt I wanted to have clarified. First of all, the fact that the unconformity there. and that generally the Stanmore gravel is at the surface, even though, well, okay. So I'm just struggling to put the picture together in my head. I don't know if anybody else in the meeting is feeling the same as me, a little bit confused about the distribution of the Stanmore gravel. As I said, I have a question about what that means about the westward correlative of the red crag and the vertical crustal movements in the London region. So those are my questions, really. And then I was going to introduce the Quaternary, the Thames, but maybe it would be better to ask David Bridgland to come in at this point. Is there anything you can help us with on what's been said so far?
Yes, if you're ready to hear from me.
Yes,
I think there's a bit of confusion resulting from the various sources that you've picked this up from. I think for red crag, I would perhaps suggest red herring, because I don't think it's got anything to do with the red crag. I don't think it's as old as the red crag. And I don't personally think there's any doubt that it's fluvial. And I've seen pictures of some of your pebbles, which look like fluvial pebbles to me. But of course, the vast majority of them are tertiary marine pebbles that have been reworked, which is why it used to be called pebble gravel. And I called it Stanmore pebble gravel, but I only apply that name to the stuff at Stanmore Harrow Common, forming the higher terrace of what I think is a sort of Molway, Wandle type tributary flowing from the southwest of London. Certainly, I'd link it to the Dollis Hill gravel, which you showed on that section, that cross section from the London Geodiversity Partnership. Was it linked to the Di Clements field trip from 2011? I think it was. I have a lower pebble gravel. I think I called it Northall pebble gravel, which is distinctly lower and occurs at north of Great Wood. And I think those are two terraces at least of a substantial South Bank tributary, which was probably formed from a combination of those rivers, just as the Dollis Hill gravel was. And Phil Gibbard worked that out when he did his PhD on Western London and the Wales St Albans. And he traced the diversion of the Thames later in the Pleistocene in that western northern area of London, western and northern area of London. And I kind of completed the story by looking at it in Essex. So I'm off my patch here, really. I'm further north and west from my patch, but I did get the job of looking at all the Thames Quaternary potential for the GCR. The Quaternary of the Thames was the publication of the GCR, the Geological Conservation Review, still being done in those days by the Nature Conservancy Council as it was, and the Joint Nature Conservation Committee, which still exists just about, I think, but has no geologists working for it anymore. And you probably know that the continued publication of the Geological Conservation Review is being done in the Proceedings of the Geologists Association. So we've got more of the Quaternary SSSIs to be published in that. And we've got updates of some of the Thames ones, actually, when they finally get around to publishing them. They've been drafted. So I saw some of your pebbles looking broken and then rolled in a river, and rather than on a beach. And I mean, that's the sort of thing you need to look at a lot of to be convinced that that's what they're telling you. So you can do an angularity roundness analysis of flint. Flint is particularly good at it because only beaches get flint as round as most of those pebbles are. And I think only tertiary beaches or the tertiary marine environment got them quite so perfectly round. You'll struggle to find flints as round as that on most of our South Coast beaches now. I know because I've looked. You need a beach that is a real storm beach with a big fetch and has been there for a while to get them as round as that. So some of the Dungeness ones are quite nicely rounded, but beaches along the South Coast in West Sussex, for instance, not very well rounded. I've analysed the Boxgrove beach and some of the other ones down there in West Sussex. They're not particularly well rounded, but they're better rounded than a river can get flint. Even a big river like the Thames doesn't round flint to form round pebbles, not unless it's really weathered and rotten. It just rounds the edges so that you get what you'd classify as subangular or very occasionally sub-rounded, but really angular and subangular is what you get in in river gravels. So, and I haven't done that on the Stanmore gravel, or any of the other gravels in this northwestern part of London. And but I have published a lot of that sort of stuff as a peripheral part of studies of things like the Box Grove area and so on. So that would be, you were asking about how you could do some research on this. Even if you can't find an exposure that you can convince me, Peter Allen, people like that, that it's actually in situ bedded fluvial gravel or even marine gravel, because I haven't seen that in your images. And I think somebody hit the spot when they said it's got a lot of soil in it. I wonder if this gravel is well enough preserved, thick enough, undisturbed enough to actually retain its bedding. I think it might just be what some of the old writers would have called the wreck of a deposit that's just sitting there, perched on a hill, incorporated in the soil. And small patches of gravel, of ancient gravel, often are in that sort of condition. But you can still study the pebbles. You can't the gravel size material. Pebble is a term that I think I associate with a rounded marine gravel rather than a river gravel, which I would call gravel. But of course, this stuff was called pebble gravel by the old geologists because it is 90%, 95% reworked rounded flint from the tertiary, which was everywhere when it was deposited. So the tertiary filling of the London basin had hardly been touched by erosion when these ancient gravels were formed. The chalk wasn't exposed as well as it is now. So there wasn't that much fresh flint being added to it. A lot of the subangular flint in this gravel was probably broken tertiary pebbles rather than fresh flint coming from the chalk. But you might find some, and of course you've got mention of those quartzose clasts, those quartzose gravel particles, and also green sand chert. And the green sand chert is what persuaded Wooldridge that these were fluvial gravels. He started off thinking they were marine and changed his mind to interpret them as fluvial later in his career. Wooldridge was a famous geomorphologist. He was a geologist actually, because he did things like heavy mineral analysis, but he published on what we call the Quaternary now. I believe was he at King's College, Peter? Somewhere like that. He was at a London college anyway.
I think he was at King's, and
yeah,
he's the founder of geomorphology, I would have thought.
Absolutely.
Peter Worsley might have something to say on that.
He published that famous book with David Linton, Wooldridge and Linton, and some really profound things are in there. And he's had a bit of a bad press since, but I think rather unfairly. I never met him, of course. I'm much too young. Oh. But no, he changed his mind, and I think he changed his mind in the right direction. And the green sand chert, he traced it up through the pebble gravel. And now we've had a different definition of Stanmore gravel too. That the Stanmore gravel formation is defined by the BGS, I think, in that lexicon. They give that name to high-level gravels that might have been called pebble gravel all over the place. There was Well Hill mentioned. I think I've seen a list on something you sent me that includes Langdon Hills in Essex. These are all different things. And the Worley gravels near Brentwood. These are all completely different things, and I wouldn't lump them together. They're terrible lumpers, the BGS at times. I think this Stanmore gravel is basically just here, where a river crossed from sort of south-southwest to north-northeast, heading for the Thames, not quite got there yet. And I know Peter Worsley, who's sitting there in the black, has looked at the Thames end of this thing and looked at the Nettlebed gravel, and it's as old as I thought it was when I wrote the GCR volume. But I only visited, and as I've said before, this northwestern area is not really my patch. But the Langdon Hills gravel in Essex, I have studied. I've done stone counts and angularity analysis on those, and I am absolutely convinced they are the Darren. They are the only deposit north of the present Thames of the Darren, because I think quite early on, the Darren was captured by the Medway via a tributary of the Medway, which was the river that eventually the Thames was diverted into. And maybe the Worley gravels have got something to do with that river. And I think there's all sorts of exciting things that could be done with these high-level gravels.